I don't know if it is recorded now. In BBD, it's recording, but I can see that I have some very alright. Need to hold on. It's being recorded now. Wait lang po ah. I think it's being recorded now. Okay, good afternoon everyone, and this is our week number 4, I believe. And we'll be talking about clustering, some of the unsupervised machine learning algorithms will be discussed today. And at the end of this day, we'll be able to understand and demonstrate some of the typical unsupervised machine learning methods, especially clustering, and it will be reported by your classmates. And then later, we'll be talking about Perceptron, which is the simplest neural network, and then we'll talk about neural network, of course. And then without further ado, let's proceed with the first reporter. The topic will be reported by uh, The topic will be reported by Mr. Baldomar Raulde. Go ahead, sir.
Can you see my screen now, sir?
Yes, I can see. Okay. Is it okay if you turn on your camera?
Ay, wait lang, sir. Can you see me now, sir?
I can see a black screen. Maybe it's still loading. You can go ahead na. Siguro. Yan, oh, you're using what do you call that? Chroma cam?
It's still black, sir, on my end.
Yeah.
Ay.
Yeah, it's okay now. I can see you. Go ahead, sir.
Clustering methods, because I believe the scientific clustering methods and algorithms will be discussed by the next presenters. Bali, first off, what is clustering? Cluster analysis or clustering is the task of grouping a set of objects in such a way that objects in the same group are more similar to each other than those in other groups. Um, Other sources says it is also grouping of data points and creating partitions based on similarity. If the two things are similar, in some ways they share the same characteristic. In statistics naman, it is defined as a set of tools and algorithm that is used to classify different objects in such a way that it is similar in that two objects is maximal if they belong to the same group and minimal otherwise. Bali, based on the description, it's basically grouping or joining them into group with their characteristic or proximity or similarity. For the types of clustering, some sources says it has two. It is divided into hierarchical or non-hierarchical under non-hierarchical, we have partitioning, distribution-based, and density-based. Pero for the sake of the discussion, we will be dividing it into 5. The connectivity-based clustering, which is the hierarchical, centroid-based clustering, which is the partitioning method. The next one is the distribution-based, and the next one is going to be the density-based, and the last one is going to be fuzzy clustering. For hierarchical clustering method, it is an unsupervised machine learning clustering where it begins with a predefined top to bottom hierarchy of clusters. It then proceeds to perform a decomposition of the data objects based on its hierarchy, hence obtaining the cluster. This method follows two approaches based on the direction of the progress. It can be top-down approach or the bottom-up. These are, as we know it, these are called divisive approach and the agglomerative approach. Um, we have a GIF here on the right side. As you can see, the P5 and P6 are clustered together first, then followed by the P4, and then P2 and P1, then P0 and P3. They form another cluster again until they become a one big cluster. This is it uses a Euclidean distance also. Um, for the sample algorithm and application areas, we have Diana or divisive analysis and Agnes or agglomerative nesting. Um, the application areas are the following. It is widely used in DNA sequencing to analyze the evolutionary history. It also One of its application is also identifying fake news by clustering the news by assigning tokens or words of this cluster and marking out suspicious sensational words. um, the One of the major advantage of hierarchical clustering is even if you have no prior knowledge about the number of clusters, you can you can use hierarchical clustering. And one of its disadvantages, it, it has a high time complexity and it it cannot be used in a large data set. Just imagine, for example, here, we have a large data set. For example, we have 1,000 data sets. Um, it will be very hard for us to look into and visualize even if we use heat map. The next one is the centroid based clustering, and it is considered as one of the most and simplest clustering algorithms. Yet, the most effective way of creating cluster and assigning data points. Ang ang sample algorithm naman na ito, which is the widely used, is the K-means clustering. Ay, bale pala yung centroid base, the intuition behind this is that a cluster is characterized and represented by a central vector, as you can see here on the GIF on the right. And the data points that are close to its proximity, so these vectors are assigned to their respective clusters. The most popular algorithm is the K-means clustering for the centroid-based clustering. Its main application areas is document clustering, banking insurance fraud detection, image segmentation, and customer segmentation. One of the main advantage of centroid-based clustering is it can be applied in any form of data as long as it has a numerical entity. Um, on the other hand, ang disadvantage naman niya, it requires us to decide the number of k or cluster before we start the algorithm. And it cannot work on categorical data unless parang mag-one-hot encoding. The next one is the distribution-based clustering. Bali yung centroid-based clustering and hierarchical clustering is based on the proximity, similarity, or distance. Tapos yung next one is density-based, is based on density. On the other hand, this distribution-based um, is totally different because it uses probability instead. Example of this is the Gaussian Mix Models with EM. Application areas, example, GMM has been more practically used in topic mining and spectral clustering combined with Gaussian Mix Models. Ang advantage naman ng neto over the other, yung associativity niya ng data point to a cluster is quantified using probability metrics, which they say can be easily be interpreted. Ang isa naman sa mga disadvantage nito, it's hard to find clusters if the data is not Gaussian. Hence, prior starting the algorithm, there's a lot of data preparation you need to consider or required. The next one is the density-based clustering. The very definition of cluster-based on the metric, density-based clustering methods take density into the consideration instead of distances. Sample algorithm is mean shift clustering and DBScan, which I believe will be discussed later. Example application areas, image tracking, video analysis, image segmentation, and computer vision, and it is also used in document network analysis. Advantages of density-based clustering is one of its advantages is it's dependent on density and it is not limited on the circular or spherical shape as we see on centroid base. And one of the disadvantages of this method is it cannot work with data set with varying density naman. And it is sensitive to its hyperparameters, the epsilon and the minimum points, yung parang neighbors niya para mag link sa kabila into a cluster. Well, the last one is the fuzzy clustering. This algorithm, it's more para siyang k-means pero there can be overlapping in the data points. Ang sample algorithm naman nito, fuzzy c-mean and rough k-means. Ang application areas niya, ang example, image tracking of video, image segmentation, and computer vision. And it is widely used in recommendation system for various web application and e-commerce websites. Bali, para ma-recall ng mabilis, hierarchical and partitioning methods, they are based on similarity and proximity, the distance. The density base is based on the density. Distribution base is based on probability, while fuzzy clustering is more of k-means with overlapping data points. Bali, to summarize, I have here a cheat sheet for the following. For hierarchical clustering, it's based on top to bottom hierarchy of data points to create clusters. Ang advantage niya, easy to implement, the number of clusters is to be specified. Ang disadvantage niya, cluster assignment is strict and cannot be undone. high time complexity, and cannot work on large dataset. Ang sample algorithms niya, Diana and Agnes in H class. On partitioning methods, this is based on centroids and data points that are assigned into cluster based on proximity. It's easy to implement ang advantage niya, faster processing, and it can work on large data. Disadvantage, we need to specify the number of centroids in clusters to initialize the algorithm. The most used algorithms for partitioning methods are k-means, k-medians, and k-modes. For distribution base, in summary, it's based on probability distribution of the data. One advantage niya is number of clusters needs not to be specified, and ang disadvantage niya ang complex algorithm and slow, and you cannot be scaled into larger data. Ang common algorithm niya, which most used, is the Gaussian Mix Models and the BBCLASD. For density base, itong as I mentioned, it is based on density. One of its pros is it can handle noise and outliers, and disadvantages is it's complex and slow. It cannot be scaled also into larger data. Ang sikat dito sa density base is the DBScan and the mean shape clustering. For the fuzzy clustering, it's based also on partitioning approach then, but the data points can belong to more than one cluster. It can work highly overlap data in a higher rate of convergence. For the disadvantages, we need to specify the number of centroids, just like sa partitioning methods, and it is easily affected by noise and outliers. Common algorithms naman niya ay fuzzy c-means and wrap k-means. For the detailed algorithms, I think it will be discussed by the next presenters. So that's all for it, sir.
All right. So thank you so much, Mr. Baldomar, for the comprehensive report on the different types of clustering algorithms. You talk about the five types of clustering methods that are basically you can apply different algorithms, different methods, and they have their own applications, as discussed by Mr. Baldomar. For example, the hierarchical is when you want to determine the proximity, and then you talk about also the centroid base, which is also in terms of proximity as well, or the distance. And then it differs from the density base because it's not density base is based on the density, and while the distribution base is more on the probability aspect. And then yung sa fuzzy, I did not find a simple demo on that because it's more on the computer vision side. Yung mga fuzzy clustering, it is used in image recognitions, video classifications, something like that. So it's very difficult to find a very simple. You might find, but well, when you demonstrate it, it will take time to finish. Okay. So thank you so much, Mr. Baldomar, for a very nice presentation. Kindly send me na lang the email. Kindly email na lang the presentation to me. Okay, thank you, sir. And then the next reporter will be Mr. Bragais.
Yes po, sir.
Okay, sige, I'm gonna make you the presenter para you can upload your presentation, or if you want, you can just share your computer.
Sir, can you see my screen?
Yes, I can see your screen right now, and I can also see you now. So I
Okay
think,
po,
sir,
sir.
you can proceed now.
Yes po. Good afternoon, sir, and classmates. So we'll be discussing K-means clustering and mean-shift clustering. So these two methods are classified under unsupervised machine learning. So meaning, from the word unsupervised, we're not including any levels in our models. So we are just making an inference, no, based on the natural structure within data points. So that is what we mean by unsupervised machine learning. And clustering, okay, so this is one of the most uh, used algorithm. The k-means and the means it actually k-means is the most used algorithm in clustering. So I will first discuss what is k-means clustering, its concept, algorithm, and application, followed by the main shift clustering. So what is k-means clustering? So by definition, it is an supervised learning algorithm that will attempt to group similar clusters together in specific data. So the goal of k-means clustering is to divide the data and label data into distinct groups as shown in your screen. So in the screen, so there are points, no, uncolored points. So after we apply the algorithm for the k-means, it will result into different segments or we yung tinatawag natin na segmentation into groups, no? And mathematically speaking, this is the equation, the objective function for the k-means clustering. The important features for this equation is that, as we can see in our screen, there are factors affecting the result. So namely, meron tayong number of clusters, number of cases, and of course, the distances between the points or our data. So much for that equation, and we will now proceed to the explanation of how k-means clustering happens in the program. So we start by giving an example data points represented by the circles lying in a single axis. So for simplification purposes, we just lay down the data points in a single axis. So as you can see, uh, these points are unlabeled. And suppose we want to cluster these points, for example lang po, into three clusters. So these three, number three, this is the K in K-means algorithm. So we start by random selection, no? Random selection of distinct data points in the example. So we have three colors representing three distinct data points. So for example, the blue one, the blue circle, for the first selection, the green one for the second point, and the yellow circle for the last uh, point. So with this example, the next step is to measure the distance between the first point and the three initial clusters. So let me explain this illustration. So for example, uh, we want to know the first data representing by number one, no, in the circle. So saan ba talaga lagay or naka-group yung first data natin. So what we will do is to measure the distance of the first data point to the first cluster, no, which is the blue circle. Next, we will measure the distance of the first point to the second cluster, which is the green circle. And last, we will measure the distance of the first point to the last cluster, which represents by the yellow circle. So at this point, we know that, of course, the first data point is nearest to the first cluster, the blue circle. And after that, okay, we proceed to the next data point, the circle with number two numerical value inside the circle. So again, we measure the distance between the second data point to the first cluster, the blue circle, no, and again measure the distance to the green and the yellow cluster. So based on this scenario, we can include that the second data point is nearest to the second cluster, which is the green circle. And after that, we repeat the same process to the third data point. And by measuring the distances, the result will be the third data point belongs to the yellow cluster because it is nearest to the yellow cluster. And after that, the rest of the data points are closest to the yellow cluster. Then the next process is we calculate the mean. No, so the mean for each individual clusters are shown in your screen. No, the division, the lines between each colored circles. Okay, and then after that, there is still a process. We repeat the process that we have done earlier, but in our case, we will do that with respect to the mean value. No? For example, the mean value or the distance, we measured first the distance of the mean value between the blue clusters, no, and after that we will have the following result. So using k-means clustering, using the same process but with respect to the mean values, we can see at the above illustration, the upper part, no, there is something missing or medyo mali sa ating mga mata. So based
Job,
in our
sabihin mo kay
human
Mama,
eye,
timplahan ako ng kape.
the correct,
Naantok ako.
the correct clustering of colors is shown in the is shown below in the screen, no. So dapat ganun dapat yung yung result or yung arrangement ng mga kulay based dun sa mga clusters natin. So ano bang gagawin natin? Okay? So in order for us to maximize the quality of the clustering, we will use the variation, or in other words, we will assess the quality of clustering. So we can do that by adding up the variation within the cluster. For example, in the screen, you will see that the above result, the different color clusters, the horizontal line indicated in the slide are the variation, no? So for example, the blue clusters and I think the green clusters have more or less equal variation, no? And the yellow cluster has the highest variation. So if we will just visualize the variation, ganito yung mangyari sa atin, no? So meaning mukhang kulang pa yun na natin yung process. And take note that K-means clustering cannot see the best clustering. So in order for us to quote in quote see the best clustering, we need to keep track the clusters and their variants with different starting points. So with that said, ibig sabihin niyan, we will start again. We will start again.
Matibungan muna ng malamig na
we will
konti.
go back to square one. But in our case, we will pick new clusters in different locations compared kanina. So in our case, ganito na yung natin, yung napiling mga locations for the three clusters, the blue, green, and yellow. After that, we apply the same process as we did earlier. So it will result to this clustering, no? And after that, using the same process, but with with reference to the mean. So ito na yung mangyari sa kanya. After that, okay, we again measure the distance between every points with respect to the mean, and we label the point, a color in which pinakamalapit dun sa mean. So it will result like this.
Thanks.
Okay. And we will repeat the process until the clusters no longer change. As you can see, in terms of the variation, medyo pare-parehas na yung mga variations ng mga tatlong clusters with respect kanina. So this variation, the total variation within this example, is based on our selection, which is k equals 3. Okay. Anyway, what's this? Okay. So based on those attempts, we can okay. So sorry for that. Nagkamali ata ako ng edit kanina. So anyway, so based on that attempts, the clustering methods we have done earlier, so we can see that the second attempt that we just did has equally or has equal length in terms of the variation. So the question is that how do we figure out what is the best value for k? Now, for example, we will select k equals 4. There will be 4 clusters. So kapag ganito yung nangyari, the total variation for each cluster is smaller compared to the k with less value, or each time we add a new cluster, the total variation within each cluster is smaller than before. So if we can just plot the variation reduction, with respect to the number of clusters, we can see in this slide. As we progress from cluster 1 2 in 3, we can see that, or we can observe that there is a huge reduction, no, from the number of clusters starting from 1 to 3. There is a huge reduction. But after the cluster, k equals 3, the reduction does not somehow dramatic. Ika nga. So this point, the point where the plot intersect with the number 3, k equals 3. This is called the elbow plot. So the best value for k is can be determined by finding the elbow in the plot. So in our case, for example, the best value for k is equal to 3. So this is uh, uh, an example, or this is based on our example on the points lying on a single line or a single axis. But what if we have two-dimensional data points? So we can cluster, or we can use clustering, based on the distances, or yung hinahanap natin yung centroid, no? So the star in the graph represents the centroids uh, for the three clusters, for the individual cluster. So there are many methods for determining the distances, or the distance between two points. Meron dyan na Euclidean, cosine, Manhattan, or may iba pa pang mga ano dyan, mga processes. But we're using Euclidean method. So yung Euclidean, this is based on the Pythagorean theorem. This is the the most commonly used formula for getting the distance between 2 points in algebra, in mathematics, basic mathematics. Okay, so to implement that in our Python, in Python, we just include the libraries, and for the sake of this presentation, we will make use of the built-in data set, which is the make blobs from the scalar library. So in this slide, okay, we set the parameter in the line 3, and cell number 3, we set the parameters, and then in line 4, we just show the graph using scatter plot. Okay, so based on this illustration, the points are unlabeled. So wala pang mga labeled yan. Hindi pa siya nag-group into different sections or segment yung data points. And to apply the k-means, we just use the scalar and import k-means. Ganun lang siya kadali. And for us to know or to find the best value for k, we will use the elbow method, which I just explained earlier. So yung cell number 6, dito nakalagay yung code for showing the plot, the elbow plot for the optimal number of clusters. So based on this plot, we can deduce that the best value for k is the 4. The 4. The x-axis in the graph is the number of clusters, while the y-axis in the graph shows the what they call this, the WSCC. Yung iba tawag dyan ay within cluster sum of the square. So within cluster sum of the square. So ano bang ginagawa ng WC? Tama ba yan ako? WCSS. So ano bang ginagawa nito? So it means that it shows the total, or it measures the compactness of clustering, and we want it to be as small as possible. Okay, so again, based on this graph, the best value for k is 4 based on our analysis. So for demonstration purposes only, to demonstrate what will happen if we change the value for k, no? So instead of 4, we want different values. So ito yung mangyayari sa kanya. For example, we set the k is equal to 1. So based dito sa ating screen, isa lang yung na-label. So lahat ng mga points doon, isang kulay lang naman. So ibig sabihin, pag isang kulay lang naman, isa lang yung na, ano yan, na group dun sa given data point or data points. So what if k is equal to 2? So kapag dalawa na siya, k equals to 2, mangyari dyan, yung unlabeled data points natin, as you can see in your screen, na-group na siya into 2, no? Into 2 groups. The red cluster and the violet cluster, no? So dalawa lang yung kulay. Ibig sabihin dalawa yung groupings na ano niya or dalawa yung na-infer niyang distinct characteristics based dun sa data points, mga data points. And if k is equal to 3, of course, merong makikita ka dyan na tatlong kulay representing 3 clusters. And of course, yung k natin, 4 yung makikita nilang kulay representing 4 clusters, no? And usually yung mga applications, okay, isa lang to sa mga applications ng k-means clustering. Ginagamit ito sa clusters, pag-cluster ng mga similar documents, pag-cluster ng mga customers based sa mga kanilang features. Ginagamit rin ito dun sa market segmentation, and ginagamit ito sa pag-identify ng mga similar physical groups. And isa sa mga gamit ito yung gamit ng clustering ay ginagamit dun sa pag-evaluate ng mga performance ng mga estudyante. So for example, in this publication titled Application of K-Means Clustering Algorithm for Prediction of Students' Academic Performance. So based dito sa research, yung mga researchers ay gumamit ng K-Means Clustering Algorithm para ma-determine yung performance ng mga estudyante. Ito po. So meron tayo dito nga data. So as you can see, meron tayo dito yung first column for the number of clusters, yung second column naman for the cluster size, and of course yung last column para dun sa overall performance, no? Okay. So based on the graph, so punta lang tayo sa graph para madaling intindihin. So nakalagay diyan figure 3 na kinuha natin dun sa paper. So there are 3 clusters. If we increase the number of cluster doon sa ating algorithm, so as you can see, meron ng mga distinct na mga grupo, no, doon sa graph natin. Okay, and for the k equals 5, okay, mas tawag dito, nagiging obvious yung mga natin yung group of students based dun sa clusters, kung sino ba nakakuha ng very good, excellent, rating, mga ganon, no? So based in sa natin sa K-means algorithm. So that ends my presentation for the K-means. So we will proceed dito sa ating meron tayong isang algorithm, which is the mean shift algorithm. So this algorithm tries to find the dense areas in the smooth density of data points. So this is an example of a centroid-based model, centroid-based model that works on updating the candidates for centroid to be the center of the points within a given period. To give you a simple illustration, okay, let's say we have many data points, as you can see in your screen. Now, the goal of the mean shift algorithm is to find the mode, find the mode of the distribution. That's the goal of the mean shift algorithm. So in our case, the mode of distribution is somehow located at the at that area as shown by our cross, color green cross, but anyway, so that's a location of our mode of distribution. So ano ba yung unang gagawin natin? We will place circle. So this circle is called the region of space in some literature, no? And the circle has a center. Of course, every circle has a center, And if we just find or calculate the center of mass, or ito yung sinasabi na natin na mean, so dun siya sa at the cross, violet cross. Okay? As shown in the illustration. Okay? So, kapag meron na tayong region of space, and meron na tayong nakuhang center of mass based dun sa mga data points natin, pag kinuha natin yung tawag dito, yung difference nilang dalawa, the difference between the center of the circle and the center of mass, yun na yung tinatawag natin na mean shift vector. So, ano yung gagawin natin? Para makuha natin yung goal natin or maating yung goal, which is the mode of the distribution, we will just shift. Kaya nga tinawag siyang shift. We will just shift the center of the circle to the center of mass as computed in this illustration. So, ang mangyayari dyan, ito na po siya mangyayari. So, from here, this is the original location. Okay, nag-shift lang yung center ng circle natin, yung range of space, dito sa center of mass. Yeah, that is the new location of our circle. Next, gawin natin ulit yung process. Ganun, ulit-ulitin natin. So, in our present circle, we just compute, we have to compute again the center of mass. Now, for example, nakuha mo na yung center of mass. Again, you will just shift the center of the circle to the center of mass. Okay, as shown in the illustration. No? So, you just repeat the process. Just repeat the process until makuha mo yung mode of the distribution. So, again, okay. So, the goal of the mean shift algorithm is to find the mode of the distribution, and you just, for simplicity, you just select any region of space. For example, dito sa ating illustration, mamit ng circle, then you find the center of mass within the boundary of that circle. After that, you shift we shifted the center of the circle dun sa center of mass, no? And meron ka naman center of mass ulit. Okay, i-shift ulit dun yung center hanggang makapunta ka dun sa mode, no? Or yun na yung tinatawag natin na highest distribution dun sa, or highest density distribution dun sa mga data points. Okay. So, one of the applications ng mean shift algorithm ay ginagamit po dun sa pag-track ng mga objects, especially sa computer vision, no? Okay, so for example, meron tayo ditong picture. So yung goal natin ay matrack yung motion ng babae as indicated by the red rectangle. So using the mean shift algorithm, so yan, na-track naman, okay, accurately yung motion based dun sa algorithm. But of course, algorithm lang naman to. Madami pang mga kailangan na gawin kasi madami pa tayong pwedeng gawin or i-import para magawa to. Okay, so but that is beyond our scope kasi nasa na siya computer vision topic. So that ends my presentation. So thank you po. Salamat po sir and classmates sa kanilang participation.
Thank you very much, sir. Very interesting topics that you have, and of course the examples that you have given are papers whose examples are on k-means and mean shift. I would like to clarify on how do you calculate how do you calculate the when you are in the k-means? Now I'm talking about k-means. There is an algorithm that after you cluster them, You compute the nearest values, and then you get the mean, and then you cluster them with respect to the mean, right?
Yes, sir. That is for the single line example for the data points.
Yeah. But what if we have what if the points are scattered?
We just use the formula. For example, we will use the Euclidean method for the determining the distances between the 2 points. So, for example, if there are many scattered data points in a chart, so we can use the Euclidean method in order for us to find the what they call this, the centroid. And after that, we just iterate it, provided that the new centroid will be our new location for the computed data set.
Okay. So it's amazing that you were able to explain it to us very slowly, no? Kasi when we perform that in an algorithm using scikit-learn, it's very fast, no? The execution of k-means is very fast and quick, no? But it's actually very, when you try to describe it, I was able to understand it very clear. And I hope that your classmate also understood it clearly, no? Especially on the part that to be able to get the the best cluster or the number of cluster is you should be able to use the method called elbow. And then yun naman sa mean shift, no? I'm inviting your classmates if they have some questions, no, including the first report na diniscuss natin, yung sa report ni Mr. Baldomar. If you have some questions po, kindly type in na lang your questions on our public chat. All right. Otherwise, thank you so much, Mr. Bragais, if there are no more questions from your classmate. Very nice report. Thank you. Let's move on with our next reporter, si Miss Joy Lakbawan. You are now the presenter. Hello, Miss Joy. I think you don't have audio. Naayos pa niya. Ayun. Parang medyo grounded siya. All right, we will wait for you. And also, you are now the presenter, so you can present your presentation. Yan, parang may alien dyan.
Can you hear me?
Yes, pero medyo parang grounded siya. Parang medyo...
Transfer lang ako ng Is it clear? Hello?
Yeah, we can hear you, but it's parang medyo merong mga static. May interferences.
Ganyan, sir. Okay na?
Yan, okay na siguro yan. Palagay ko hindi na mawawala yung naririnig namin. We can bear with it.
Okay, sorry about that. Okay, so I'll start my presentation.
Ooh. What kind of microphone are you using?
Here I have a green USB type from na brand. I don't know bakit hindi siya gumagana. But I'm using now my tawag dito, earphone.
Hmm.
Anyway,
You're using your
let's start the
earphones.
presentation.
Kasi parang medyo maingay. Hindi clear yung audio mo.
Walang po.
Sige, it's okay. Don't worry.
Okay. So I'll be discussing the scan algorithm and expectation maximization using clustering using and
Have you
hello,
displayed your PowerPoint presentation yet? Kasi wala pa kaming
sorry.
nakikita. It's not displayed yet.
So I'm sharing my screen now.
Wait lang ah. Okay. Ayan. I'll make you the presenter kasi dalawa yung account mo pala kanina. So you can share now the
Yes,
presentation.
sorry. Can you see my screen?
We can't see it yet.
Ayan, can you see my screen?
Not yet. And it's sharing right now. We can see your screen right now. Siguro pwede nang mag-start.
Okay. So I'll be discussing the scan algorithm and expectation maximization algorithm using DSM. So let's start with DBSCAN. So DBSCAN stands for Density-Based Spatial Clustering of Applications with Noise. It is the most well-known density-based clustering. So in density-based clustering, the algorithm identifies dense clusters of points, allowing it to learn clusters of arbitrary shapes and identify outliers in the data. It was first introduced in 1996 by Esther, Fidel, Sander, and Chu. Due to its importance in both theory and application, in 2013, this algorithm was awarded the Test of Time Award at the Association for Computing Machinery's Special Interest Group on Knowledge Discovery and Data Mining. So this then uses the concept of reachability and connectivity. Reachability in terms of density sets up a point to be reachable from another if it lies within a distance of epsilon, that is, the radius of the frequency. Connectivity involves a sensitivity-based screening approach to determining whether points are located in a particular cluster. Thus, it requires two parameters: the minimum point, which is the minimum number of points clustered together for a region to be considered dense. In other words, the minimum number of data points you want in a neighborhood to define a cluster. Another parameter is the epsilon. It is a distance measure that will be used to know how far away a point needs to be considered part of the cluster. To see how this can work, we have to determine the type of point. Each point in the data set can be either a core, border, or node point. A data point is a core point if within the neighborhood of the point there are at least minimum points. In the illustration, the red point is the core point because there are at least 4 points within the distance of the set epsilon. A data point is a border point if its neighborhood contains less than minimum data points or it is a subversion from core point. Integrity means it is within the distance from a core point. An outlier or noise point is a point that is not core point and also is not close enough to be reachable from a core point. So let's see how this algorithm works. In the process of clustering, the algorithm randomly selects a core point as the initial point and takes all the core points in its neighborhood for continuous expansion. The expansion ends until the maximal set of density connected samples is found and labeled as one cluster. After that, the algorithm randomly chooses other unlabeled core points for generating new clusters. So the process of clustering completes when all data points are labeled. In the illustration, the algorithm generated 4 clusters. So the whole idea behind the DB-span algorithm is to visit each point and find its type first, then group the points as clusters based on their type. Let's see the implementation of DB-span in action. So to illustrate, we download the DB-span GitHub. DB-span can be imported from a Silverine library. So in here, the author used the Canada weather data for the year 2014 to find the group of weather stations which shows the same weather conditions. The 1,200 stations were plotted to see where the locations are. So choosing the temperature and map projections of coordinates of seasons and setting the epsilon and minimum points to points 3 and 10 respectively, we get this result. So based on location and temperature, it resulted to a smooth cluster, the left image. If classification is included as additional feature and repeated between clustering steps with epsilon and minimum points set to 0.5 and 10, there will be 4 clusters, or the left image. So from the results, we see that these can found and clustered the denser part of data-centered samples by ignoring less dense areas or the nonsense. Let's see now the advantages and disadvantages of DB-span. First, it does not require a number of clusters as input. DB-span will automatically determine the clusters, dependent on how close points are from one another. It performs well with arbitrary shaped clusters, so clusters can take any irregular shape, unlike streaming where clusters are more or less spherical. Another advantage is it is robust to outliers, so outliers are not determined to be part of a particular cluster. So some weaknesses, it will not do well with clusters of different densities. And choosing a meaningful epsilon value can be difficult if the data isn't well understood. So this is an example of the application of DB-span. This research paper by Hogan et al. Entitled "On the Use of Clustering Analysis for Identification of Unsafe Spaces in an Urban Traffic Network." We have applied K-means clustering and DB-span in order to identify the locations of cyclists perceived unsafety in an urban traffic network, so-called the bicycle impediment. They use data collected by cyclists traveling in Sweden, where each data point defines a location and time when a cyclist reported to feel unsafe. The cyclists were instructed to click a button mounted on their handlebars when they felt unsafe in the traffic station. Each of the clicks or the data point contains the unique button identifier, the GPS coordinates, the GPS accuracy, and a timestamp of the click. The buttons were connected via Bluetooth to the cyclist's phone, which in turn communicated each button click to a server. These data points were then clustered using an iterative K-means clustering with outlier detection approach, which we have used in order to identify an appropriate value of K and to remove outliers from the dataset. We also applied DB-span to complement the clusters generated by K-means by identifying those extended clusters that could not be identified between figures. The results of the clustering was presented to the trust management
Napabukas ng ilaw, ah.
to confirm that the vertical impediments that they have
Thanks.
identified represented by clusters appear to be reasonable. In particular, they were able to explain several of the impediments, whereas some of them were previously unknown. So let's now go to expectation maximization using GMM. So expectation maximization is an iterative method to find maximum likelihood estimate of parameters in a statistical model, where the model depends on an observed latent variable. An observed latent variables or hidden variables is inferred from the observed variables. So expectation maximization algorithm tries to use the existing data to determine the optimum values for these variables and then finds the model parameters. The 1977 Dempster, Laird, and Sidney paper established this model. So how does the algorithm work? First, a set of initial values of the parameters are considered. So a set of incomplete observed data is given to the system with assumption that the observed data comes from a specific model. Next is the expectation step. In this step, observed data are used to estimate and get the values of the missing or incomplete data. It is used to update the variable. In the maximization step, complete data generated from the expectation step is used to update the values of the parameters. Last step is setting of convergence, where the values are set whether converging or not. If yes, they stop. Otherwise, this is the expectation maximization step until the convergence occurs. So the concept of convergence in probability is based on the intuition that two random variables are close to each other if there is a high probability that the difference is very small. The common application of the EM algorithm is for clustering with a mixture model like the Gaussian mixture model, where it uses a combination of a Gaussian or the normal probability distribution and requires the estimation of the mean and standard deviation parameters for each. A Gaussian distribution has a bell-shaped curve with observations symmetrically distributed around the mean and the average value. The main assumption of this model is that there are a certain number of Gaussian distributions, and each of these distributions represents a cluster. Hence, a Gaussian mixture model tries to group the observations belonging to a single distribution together. So let's see how EM algorithm works in Gaussian mixture model. When given the number of clusters for a Gaussian mixture model, the EM algorithm tries to figure out the parameters of these Gaussian distributions into basic steps. The expectations where data points are assigned to a Gaussian cluster and probabilities are calculated that they belong to that cluster. Then step 2, maximization, where the mean, covariance, and density are calculated for clusters based on the data points in the expectation step. The process is repeated with the calculated value continuing to be updated until the convergence is reached. Implementing GMM in Python. The Gaussian mixture object from SK will implement the expectation maximization algorithm for fitting mixture of Gaussian models. The M component parameter is clearly set by the number of clusters. So in this example, we also use 4 clusters to segment customers based on spending, community, and income. So customers with high income and high spending amount will group together separate from the new customers with similar income and spending. So if you note this, GMM is somewhat similar to clearance, like we were before. So in K-means, clusters are defined by the means, whereas in Gaussian Mix Models, they are defined by the means and the variance in other clusters. In K-means, clusters are overlapping, whereas in GLM, it works if clusters are overlapping. Also, lastly, K-means uses the Euclidean distance to the mean, while in GLM, it uses the probability of explaining to the class. So this is an example of a repeat case for using the expectation optimization algorithm using GNN. So they use the EM algorithm to segment those missing areas in the image and then use random classifiers as classified. Okay. Thank you. That ends my presentation.
Thank you very much, Miss Joy Lakbawan. And medyo marami lang outliers. Yung ano niya, yung microphone mo, maraming outliers. So hindi natin masyadong nakuha yung centroid. Okay, so pero anyway, I saw your presentation and as much as possible I'm trying to track the best cluster. Okay. And naintindihan naman yung report mo, although I don't know kung naintindihan nila. If there are some questions, please type in your questions na lang para lalo ninyong maintindihan. Anyway, the concept that was discussed by Ms. Lakbawan is on two of the density-based algorithm, no? Yung DB-scan, and the other one is the Gaussian mixture model. So these are commonly applied in what again are the application of this? I cannot recall the paper, yung paper na ano mo, ano yung naging application nila dun sa paper na yun?
Sorry, they use this time to identify.
To identify the?
Yeah.
To identify the?
Bicycle impediment. Yung mga unsafe areas included yung mga students.
Okay, sige. Thank you, Ms. Lakbawan. So kung may questions po yung mga classmates, pwede na tayong magtanong for and if none, we can proceed with the next because we are now at I think 6 o'clock na tayo. It's already 6 o'clock. So I think the next reporters will give me time to demonstrate later. We still have 3 reporters left and we spend around 1.5 hours to do that. So let's call on Miss Trakenya now, our last student from the list here. You're now the presenter, Miss Michelle Trakenya.
Okay, sir. Sir, I think I am having a problem with my webcam. Can I proceed without?
Yeah, sure. You can turn it off if you want. Especially if it affects your bandwidth, no?
Okay, sir. Thank you. Can you see my screen?
Yes, we can. We can see it now. You can proceed now. You can start.
Yes. So, good afternoon. My topics for this afternoon are agglomerative, hierarchical, and affinity propagation. These reports will cover the background, application, the algorithm, and sample case study of this model. First, let's take a look at the HEC or hierarchical clustering algorithm definition, which was mentioned earlier. So it is another popular unsupervised machine learning algorithm. It is able to group unlabeled data into clusters. And the main output of this cluster is in dendrogram, which shows the hierarchical relationship between the cluster. This is the graphical representation of this dendrogram. It is most commonly created as an output from this cluster. So we have two types of hierarchical clustering, which is agglomerative. This is it works in a bottom-up manner. So each object is initially considered as a single element cluster. At each step of the algorithm, the two clusters that are the most similar are combined into new bigger cluster. So in this example, we assign each point to an individual cluster in this technique. So suppose there are 15 data points. We will assign each of these points to cluster. Hence, we have 15 clusters in the beginning. So contrary to agglomerative clustering, divisible clustering works in the opposite way. Instead of starting with n clusters, we start in a single clusters and assign all points to that cluster. So going back to agglomerative clustering, since the clustering algorithms have a long history, they originated in anthropology by Driver and Grover in 1932. Then in 1967, one of the most useful and simple clustering, which is the k-means, has been proposed. And since then, a lot of classical algorithms like fuzzy c-means and hierarchical agglomerative clustering have emerged. So let's look at the application of this agglomerative clustering. So we can use it in market segmentations. It is using in unsupervised learning algorithm. We can cluster all customers for different groups using different market segmentations. It can also use in search engines. It can be used in grouping the search results based on the similarity of the results, so we can improve the performance of the search. And in terms of recommendation systems, depending on what we are looking for in a recommendation system, it will repeatedly recommend other things in the same group. So a clustering algorithm is used, therefore, for this application. And last is for the image segmentations. The classification of an image into different groups can be explored using this clustering algorithm. It can read an image and cluster it to different regions, or it can represent a specific class with this method. So let's have a quick review on how hierarchical clustering works. Unlike k-means, it doesn't require the user to specify the number of cluster beforehand. Instead, it returns an output that can be seen in dendrogram. It measures the distance between each cluster and combine the nearest pair of clusters. In this way, the adjacent cluster pair merges and finally give us a single cluster with all data points. In this example, it follows a bottom-up approach, which can be seen here in dendrogram. In finding the optimal number of clusters using the dendrogram, we can use the dendrogram to produce the hierarchical clustering to see if it suggests a particular number of clusters. Now let's focus on agglomerative clustering. With this simple dummy data set, it was named in alphabetical order of the English alphabet. In this way, we have 7 data points, which is the A, B, C, D, E, F, and G. As mentioned earlier, we assign each point to an individual cluster in this technique. Each data points belong to a separate cluster. So here we have 7 clusters, and the centers of these clusters are located on data points. The centers are shown in red marks. With this, we want to determine a way to compute the distance between these points. So we try to find the shortest distance between any 2 data points to form a cluster. To select the nearest pair of cluster, we can use the methods like Euclidean distance, Manhattan distance, and cosine. Once we find those with the least distance between them, we start grouping them together and find the nearest pair of clusters. So it can combine the pair into a single cluster. As you can see here, there are now 6 clusters. We were able to cluster E and F. This is represented in a tree-like structure, which is the dendrogram. Here you can see it. Then we start grouping them together and form a cluster of multiple points. So as a result, we have 2 groups. We have this EF and AB. Similarly, we have 2 dendrograms here, as shown here. And in the next step, EF, and D are grouped, and it is now under one dendrogram because they are close together compared to G. Here we can see it here that it is close compared to G. And we do this until we finish with one cluster and finally bring everything together. You can see how the cluster on the right went to top with one cluster connecting them all. So this family of algorithms requires calculating the distance between clusters. So different metrics are used for this purpose, like simple linkage, complete linkage, average, and centroid line. But according to the most effective and popular is the word distance. It minimizes the total within cluster variance while combining the 2 clusters. So some pros of this algorithm is it is simple and works well when data has a hierarchical structure and knowledge about the number of clusters is not necessary. However, one of its cons is it requires additional analysis to choose the resulting number of clusters. So here is the simple case study of hierarchical. It is for image classification in dermatology towards mobile deploying. It is published last 2020 by European Federation for Medical Informatics. So it revolves around the skin cancer, since skin cancer is increasingly worrying medical problem, and artificial intelligence solutions have proved increasing performance in the recent approaches for cancer diagnosis. So they propose a combined approach of desktop mobile application employing the hierarchical clustering for image classification to diagnose this disease. Actually, they use the two types of hierarchical methods, which is the agglomerative and divisive, which is the top-down. They also use 3 linkage criteria: the single, the complete, and the average linkage. Also, they use the 2 metrics to measure the dissimilarity between the set of images, which is the Euclidean and the Manhattan distances. For image collection, it went to their image generation, and from then, the clustering methods were implemented. So far, they were able to have an accuracy of 73% with 95% confidence intervals. So for the next topic, the affinity propagation, it was published in 2007 by Brendan Frey and Delbert Dubek. So basically, it is still on its infancy compared to the other clustering algorithm. And this algorithm exchanges messages between pairs of data points until a set of exemplars emerges, which with each exemplar corresponds to a cluster. So exemplar is a data point that is nicely representative of itself and some other data points. So here are the application where we can apply this model. So it can be applied whenever there is a way to measure or per compute a number for each pair of data points that indicates how similar they are. High values indicates high similarity, while low values indicate low similarity. This algorithm has previously been applied successfully in biometrics for analysis of microarray and gene expression. However, since this cluster is still in infancy, it's still evolving, it can also be used in traffic analysis, where we can obtain the traffic accident cluster and identify the accident-prone location. It can also be used in identifying patterns in audio streams and in computer vision. So as mentioned earlier, affinity propagation is transferring an idea to people who then transfer it to others. So this clustering algorithm is completely different from the others in the way that it clusters its data. So in contrast to the other traditional clustering method, affinity propagation does not require to specify the number of clusters. So let us use this analogy. It is proposed by Christian Versluth. So this its concept is on message passing. It is like a gossip style algorithm which derives the number of clusters by mimicking social group formation by passing messages about the popularity of individuals. So each data points communicate with all other data points to know kung ano yung pagkakaparehas nila, and from then they start to really reveal the clusters in that data. So as the message sent between data points, yung set ng data na yun is nakakabuo na ng exemplars, and it can represent now the clusters. So when an exemplar is found, after the data points have passed the message to each other, maka-form na siya ng consensus points, data points that can represent the cluster. So this image here clearly shows how they communicate with each other first, and after ma-identifying similarities nila, it starts to form their own clusters. So some of the pros of this method is the knowledge about the number of clusters is not necessary. And however, it works so much slower compared to the other algorithms due to computational complexity. So here is the sample case study about this algorithm. defining objective cluster for rabies virus sequences using affinity propagation clustering. So it revolves around the rabies, which is caused by Lisa viruses, more than 21,000 sequences of rabies viruses from the prototype species in recent years has been deposited in public database. However, they have this problem where technical difficulties in defining the criteria for cluster allocation is found. So they propose a standardized classification utilizing these sequences using the new mathematical clustering algorithm, which is the affinity propagation. It works for any meaningful measure of similarities between data samples. So pairwise distances is calculated and merged into a distance matrix. So they use software R for this case study. So with this approach, they were able to show that this cluster based on AP might be implemented in phylogenetic software packages or sequence analysis pipelines and could help to have a transparent phylogenetic clustering. So that's the end of my report. Thank you.
Thank you so much, Ms. Trakenya. Very clear and precise ang iyong report. We learned about the two hierarchical clustering that are applied in machine learning algorithms such as the agglomerative, the older type of clustering in terms of hierarchical clustering, and then the new, which is the affinity propagation. Tanong ko lang, if you read the paper, kung they implemented affinity propagation on the rabies, right? On the classification of rabies.
Yes, sir.
What other class did they compare it with the agglomerative agglomerative clustering, or
No,
is
sir,
it is just the affinity?
yes, sir. They only focus on AP method.
Okay. Kasi if not, another paper yun, no? Pwede ka sumulat ng isa pang paper. All you have to do is to follow what they did on the affinity propagation and then implement agglomerative. If it is possible, then another paper can be published using that. No? Or maybe they are planning to do that, no? The comparison. No? Kasi pagka nagre-research tayo, we used to compare our approach to other proposed approaches, and then we compare the results, with similar data sets. We compare the results for the accuracy and the error rates. And since we're talking about classifications or clustering, so these are scored in a different way. All right. So later you'll find out how we are going to create the scores or the evaluations using clustering. Thank you, Ms. Takenya. Now let's proceed now with Miss Hanelin Cruz. Yeah. Hello, Hanelin.
Yes, sir.
Yeah, I'll
Yes,
make
sir.
you
Good
the
evening.
presenter. Yan.
Okay po.
Okay. I found out, I researched my student, hindi pala ikaw yun, si Annelyn pala yun,
Opo.
Annelyn Cruz. Okay, so iba
Annelyn.
pala. Kapangalan mo, no? Walang H lang. H lang ang differential mo. Tapos ano mo rin siya, kasigla mo rin siya.
Kabatch ko po?
Hindi, kasigla mo lang. Sigla mo lang siya, kaya parang may similarity. Kala ko ikaw yung student ko dito. Anyway,
Okay po.
yeah, you are now the presenter. You can proceed now with your presentation. Okay, Perceptron.
Okay, sige. Can you see my screen na po?
Yes, we do.
Okay.
Go ahead.
So, good evening everyone. I'm Handrin Cruz, and my presentation is about Perceptron, the first modern neural network. So this is simple and a bit straightforward. So I think it will just be a quick presentation. So let's start. So the sorry. So the flow of my presentation would be like I'll start with the history and then I'll discuss the concept or what is perceptron all about. And then I'll go with the algorithm. I'll show you how it looks like and how it works. And then I'll show you a sample code or a sample application of a perception algorithm. And then I'll show you some sample related studies. So let's start. So for the history, um, it was discovered by Frank Rosenblatt in 1958 at the Cornell Aeronautics Laboratory, and it was inspired by the Hebbian theory of synaptic plasticity. So, Hebbian theory is basically the adaptation of brain neurons during the learning process. And this invention is really good because it granted him international recognition. And to this date, the IEEE or the Institute of Electrical and Electronics Engineering, the world's largest professional association dedicated to advancing technological innovation and excellence for the benefit of humanity, named its annual award in his honor. So let's discuss now what is perceptron. So perceptron is the simplest neural network. So it's a supervised classification machine learning algorithm that makes its predictions based on a linear predictor function combining a set of weights with a feature vector. And I think we'll be able to understand it more if you see the algorithm itself and the actual code. So there are two types of perceptron. The first one is the binary classification, and then the second one is the multi-layer classification. So let's go with the binary classification. So binary classification is the task of classifying the elements of a given set into two groups based on a prescribed rule. So um, the figure on the upper right here depicts two instances of such a problem. So on the left, this one, the task is to identify the separatrix between two linearly separable classes, which means the separatrix is a simple straight line, like here. As you can see, you can separate these two classes using a straight line. While on the right side here, the two classes are non-linearly separable, which means the separatrix is not a simple straight line. As you can see, there are two clusters here, but you cannot separate those two using a straight line. Instead, you can use the circle, and it will be a different technique for that. And then the binary classification model looks like the two images below. So in here, we can see the inputs and the weights. So the inputs are the x's and the weights are w's. And if the weighted sum exceeds a predefined threshold, the neuron fires and produces an output, which is the y. So the threshold RLU or the rectified linear unit represents the activation function. So if the weighted sum of the inputs is greater than 0, the neuron outputs a value of 1. Otherwise, the output is 0. Actually, decades earlier, the activation function that was being used was the sigmoid function, and it looks like an S line, like that. And the rectified linear unit or the ReLU is like a check mark. It starts with a horizontal line and then followed by a diagonal line. So the reason why ReLU became more adopted is that it allows better optimization using the stochastic gradient descent. So stochastic, just to give a brief background, the stochastic gradient descent is merely an optimization technique. So it's only a way to train a model. So other reasons also why ReLU became more adopted is that it's more efficient when it comes to computation and it's scale invariant, meaning its characteristics are not affected by the scale of the input. And you might ask, or you might be wondering, doesn't perception actually learn the weights? Yes, it does. Perceptron uses SGD or the stochastic gradient descent to find, or you might say learn, the set of weight that minimizes the distance between the misclassified points and the decision boundary. Once the SGD converges, the data set is separated into two regions by a linear hyperplane, or the line between the classes. Although it was said that binary classification could represent any circuit and logic, the biggest criticism or downside was it couldn't represent the XOR gate or the exclusive OR, where the gate only returns 1 if the inputs are different. For example, your inputs are 1 and 0, it will return a 1. But if your inputs are either 0 or both 0 and or both 1, it will give you an output of 0. So to solve that, the scientists or the researchers found or discovered a new type of perceptron, which is the multilayer classification. So multilayer classification is a neural network where the mapping between input and output is nonlinear. So I'll just give you a brief background of this because I think um, Tristan and Tristan's report and mine overlaps, and I think you will be given a brief background about this on your report. But let's sure. Let's see. So this will be quick. I mean, this topic will just be quick on my presentation. So as you can see on the image on the right side, multilayer classification or perceptron has input and output layers and one or more hidden layers with many neurons stacked together. And while in the binary classification or the previous one, the neuron must have an activation function that imposes a threshold like the ReLU or the sigmoid that I've mentioned earlier. So neurons in a multilayer perceptron can use any arbitrary function like this. For example, this layer can use either of these three and produce an output. So multilayer perceptron falls under the category of feed-forward algorithms because the inputs are combined with the initial weights in a weighted sum and subjected to the activation function, just like the binary classification. But the difference is that each layer combination is propagated to the next layer. So which means that each layer is feeding the next one with the result of their computation, and this goes all the way through the hidden layers to the output layer. All right. So the next one is the algorithm. So let's see how it looks like. So in here, the goal of this algorithm is to find the W vector that can perfectly classify positive inputs and negative inputs in our data. So in here, we have two inputs. The first one is the P, and then the second one is the N, wherein the P are the inputs with label 1, and N are the inputs with label 0. So the first thing is we initialize W with some random vector. Then we iterate over all the examples in the data here. So we pick a random X wherein is an element of the union of the P and N. And then we have two conditions here. The first case is if X is an element of P and the dot product of W and X is less than 0, then we need to update the weight by the weight value itself plus the X. And then the next condition is if X is an element of N and the dot product of W and X is greater than or equal to 0, then we also need to update the weight by subtracting the X from itself. So if you're wondering what the dot function looks like, it's like this. It's just basically the summation of the product of weight and then the X from 0 to N. So this this code just iterates until it converges when all the inputs are classified correctly. So let me show you a sample code. that wherein this algorithm is applied. So let me see. Hmm, Let me just a second, sir. All right. So the background of this code is there is a hotel manager and he found a guest book on the lobby. And then he read some of the reviews or comments for the guests. And then he realized, oh, he had an idea of why not use these reviews to make better decisions for the hotel. So he asked one of his data scientist friends to write a code with using these reviews. So the first thing that the data scientist did was to import all the packages that are needed for these analysis or this prediction rather, and then he typed the reviews or some of the reviews from the ledger or from the guest book. So these are the reviews, and then it is assigned with some targets. And then using train test split, he split the data using a test size of zero point 0.2 and random state of 0. And then using the TF-IDF vectorizer, he removed these stop words. And then he applied transform to the trained features and transform to the test features because there are no values. There are still no values on the inputs here. So you need to use fit transform. And then he then applied it to the perception algorithm, fit it using the train data set, and then uh, he predicted it using the classifier that predicts, and then he was able to get a pretty good accuracy the of these program of these model, which is 83%. Yeah. So actually, the first trial here I got 0.64, but then I tried to play with the parameters. That's why I got 83% accuracy. So let's go back to this one. So I found some studies that use perceptron. So here are some. The first one is the asthma, Alzheimer's, and dementia disease detection based on voice recognition using multi-layer perceptron algorithm. The second one is the functional testing on heart diseases or heart disease detection using multi-layer perceptron technique. Third one is the technical analysis of cheater data in preparation of prediction using multi-layer perceptron algorithm. I still have two. The fourth one is an evolutionary multi-layer perceptron algorithm for real-time river flood prediction. And the last one is the human presence detection with thermal sensor using multi-layer perception algorithm. So I put some links here on the presentation. If you're interested, you can visit these links and maybe do some reading. And then actually these studies are good. I mean, the perception is really good because you can apply it into different fields, like here in medicine or medical field, and then in social media, as well as for environment. You can use perception to predict the river flood, as well as for storms or natural disasters, and lastly, the human presence. So that's it for my presentation. Thank you.
Thank you so much for your very uh, happy presentation. I thought you were
Thank you,
happy
sir.
reporting, doing it,
Yeah, I'm
and
excited, sir, for
yeah,
about this topic.
yeah, it's a really nice topic to begin with. No? Actually, perceptron is one of the building blocks of artificial intelligence. No? And you mentioned that it's the simplest neural network. It's actually based on our neurons. No? Inside
Yes, sir.
our, it's inside our brains. We have neurons, no, and we have billions of neurons actually, no, and those neurons are keep on firing some electrical impulses, no? And
Mhm.
it's made up of different parts, such as we have the neuron, which is the central part of it, no? And it is actually how the perceptron model was modeled, no? The neuron is the one that computes everything, and then it is connected to what we call the axon and the dendrites. No, the axons are like a typical input part, no, and it's connected to
Mhm.
other dendrites. No, the dendrites are connected. The dendrites part are actually the dendrites are the input parts, and the axon are the
Mhm.
input parts. No, and the input parts are connected to other dendrites. So all the neurons in us are a typical building block of what we call a simple uh, neural network. No, but if they are combined, they become neural networks. No, they become
Yes, sir.
multi-layer networks, and that will
Yes,
be
sir.
reported by the next one. No, next classmate, si Mr.
Mhm.
Munar. Yan. Thank you very much, Hanilin, for your nice presentation.
Thank you, sir.
And now we proceed with the last presentation, which is will be reported by Mr. Munar. Give you the let me give you the presenter.
Yeah,
All right.
yeah. Good evening, sir. Good evening, classmates.
Good evening.
Yeah,
While you're fixing the presentation, I think I will need to go to the bathroom.
yeah. There, can you see my screen now?
It's okay now. You can begin if you want.
Yeah. And good evening, everyone. So I hope everyone is well. So for today, I'll be discussing neural network. So as discussed by Hani, so some concepts were already explained by Hani and Sir Taylor. So
Tumatawag si
So for
Mama.
my
Go.
report, I'll be discussing the history of neural network, and I'll be giving an overview of
Tumatawag.
what is neural network. So, and the next is I will also discuss the process behind neural network. So I'll try to make sense of how the neural network algorithm works. And I'll also be showing some applications of the neural network, and I also added a literature review about neural network. So let's start with the history of neural network. So in 1943, Warren McCulloch and Walter Pitts published a logical calculus of ideas immanent in nervous activity. So the concept of neural network started way back in 1943. So this research sought to understand how the human brain could produce complex patterns through connected brain cells or neurons. So one of the main ideas that came
May
out of
job ng
this work
kaklase ako
was the
eh.
comparison of neurons with a binary threshold to Boolean logic, that is 0 or 1 or true or false statements. So moving forward, in 1958, as discussed by Hani, Frank Rosenblatt was credited with the development of the perceptron. So this was documented in his research, entitled the Perceptron, a probabilistic model for information storage and organization in the brain. So he takes McCulloch's and Pitt's work a step further by introducing weights to the equation. So leveraging an IBM 704, Rosenblatt was able to get a computer to learn how to distinguish cards marked on the left versus cards marked on the right. So these are some of the personalities involved in the development of neural network. So this one in 1974. So while there are numerous researchers contributed to the idea of back propagation, Paul Werbos was the first person in the US to note its application within neural networks within his PhD thesis. So the propagation concept would be explained later as we discuss as we break down the process of the neural network algorithm. So when I search for Paul Werbos, he's still currently alive at the age of 74. Yeah. Next would be in 1989. So Jan LeCun published a paper illustrating how the use of constraint in backpropagation and its integration into the neural network architecture can be used to train algorithms. So this research successfully leveraged a neural network to recognize handwritten zip codes digits produced by the U.S. Postal Service. So Jan LeCun is a prominent icon. So he is the chief AI scientist of Meta, or as we all
Facebook.
know, which is Facebook. So really we could see that the neural network has a lot of developments, and history is unfolding as we can see. So today, neural networks discussions are occurring everywhere. So the very key to the whole technology lies in the hardware development. So as the computing power develops, the capability of neural networks also increases. So later we will see the applications that we are experiencing now uh, because of neural networks. Yeah. So to understand how an artificial neural network works, we need to uh, know the real one, which is the biological.
Hello, Mr. Munar. Hello. Parang na-disconnect tayo. Did we get disconnected? Is Mr. Munar here? Nawala siya. Okay, so let's just wait for Mr. Munar. Ganda pa naman ng topic niya. Okay. I think siya lang yung may problema, no? I wasn't disconnected yata din. Can you still hear me, guys? Okay. So let's just wait for Mr. Munar. So yun, naputol pala. Can hear you. Okay, thank you. So this is what I am trying to explain a while ago, that based on this PowerPoint presentation, the neural network is designed after the operation of the neurons in our human brain. Yung simple perceptron na to on this letter B, that's the simple perceptron that was discussed by Miss Cruz kanina. No? You can see that the combination of the neurons, connecting the parts of it, no, like yung connection between the other neuron to the other one, it creates a network, and the representation of that is in letter D, which is, you can see that there are two hidden layers here. Is he already here? But basically, yung A and B are related, and this is just the human uh, equivalent, no? The biology. Yeah, yeah, you're here, and we are excited you're back. Yeah, okay. So I think you can continue now. I was explaining this, no? Yeah, this one, this slide. I think in this part, in this slide, so you're talking about artificial neural network. Yeah. So you can start explaining about this page. Ah, you cannot see it. Ah, okay. Wait. I need you to become the presenter again. Yan. Yeah, sure. No problem. Yes, we can.
naman nasagot. Sa klase ka pa ba? Ito pala eh. Kumain ako minutes. Oo, sige. Okay. Helen, yung mga damit ko mo sa labas. Kain ka naman. Helen, yung damit. Andun mo sa likod. Ang oras na lang kaya kinulit. Ano ko lang. Hey, meron ko lang. Sige. Bakit may damit dito? Ano ba meron? Nasaan si Men? Mama, nasaan yan mo? Ha? Ikayo. Dito rin. Papa, excuse na nga. Papa, bubuksan ko ito.
Be, pinatay ko yung camera.
Pwede Mimi, hindi ko makikita. Lumabas siya? Ay. Hindi ka pa. Ikaw kasama mo. Patakbo.
Okay, so thank you so much, Mr. Munar, for your very wonderful presentation. No? We learned a lot from your report, especially the part where uh, you conclude the topic with your very nice conclusion, which is we already knew why neural networks are very in demand and very practical, no, in terms of application nowadays, because there are limitations with statistics limitation with other probabilistic methods that are used. No, the advantage of neural networks, and yeah, it can be applied to artificial intelligence, deep learning, and much much related to the topic that we have discussed. You mentioned about neural networks basically can learn and they can generalize the data that we feed into it. Like a typical person, given a data, given something from a person, the normal person can learn, and that person can learn and then can generalize that particular, and that's the model of a neural network. Okay, so for our last part of our discussion today, I'll be sharing you uh, my my notebook. So where are my notebooks? So let me just check on my notebook here. Yeah, this one. This one is for clustering. And let me just share it to you. Pala, I haven't shared it yet. So let me just copy the link, type it here. So you can open that notebook. Just tell me if you are not able to open it. And let me share it to you right now. However, yeah, I can see it now. Yan. Okay. Can you see my notebook? I think you can see my notebook, no? All right. So these are some of the, I'll just reconnect so that I can access my data. So there are many clustering algorithms that was discussed a while ago, and we'll give some demonstration on that. No? But some of the algorithms are not applicable in this notebook because of time constraints, and we just want to show how typical clustering algorithm works. For example, here we have the uh, we have a data set, no? And the data set is the iris data set. So I'm sure you're familiar with iris data set. So based on the characteristics such as the sepal length, sepal width, petal length, and petal width, we are able to classify the different species of these iris plants or iris flower, whether they are setosa, virginica, and the other one I forgot. Okay, so the first thing that we need to do is to, of course, the importation of some of the uh, libraries that we need for the clustering. The most notable terms that you can see from here are the importation of the decomposition. So this decomposition, actually it's for the principal component analysis, and uh, this is a clustering type, no, of clustering type of and in some terms it's called a linear dimensionality reduction using singular value decomposition, or the SVD. Okay. So we'll have to import this principal component analysis, and then from scikit-learn we'll also import the cluster, and of course we'll be able to show you how k-means works here. As I mentioned a while ago, Mr. First Reporter, Mr. Baldomar, was able to discuss. Hindi pala, si Mr. Bragais. No? He was able to slowly show us how k-means works. No? And here, you will not see the details behind that, but basically you will see how fast k-means works, even with this plenty of data that we have. And then we'll import some metrics, and then we'll talk about linear assignments here, no? So this is what we're going to have. And yung linear sum assignment na to, why we need to import this? Because we need to optimize something later, no? On the result. No? So linear sum assignment is used to solve the linear sum assignment problem. No? So basically, we compute for the cost matrix, and we want to maximize. No? When we say optimize, it's either we do the optimization by maximization technique or minimization, depends on the objective function that we want. No? Yeah. So all we need to do is just to run the imports, and then I have the data set with me here in my data drive. I already shared to you this. So if you have access to the data set, it's better. You can also put it in your drive. Ayan. So these are the data that we have. So we just drop the last column, which is the species, because we don't need that for our training. And then we standardize all of the data. As you can see here, we standardize everything. So the standardization was from -1 to +1. Okay, and then here we do the principal component analysis. Okay, so in the principal component analysis, we place the we transform the transform or the scaled version of the scaled version of our data is basically we're putting it on data sets, and we're putting it, and we're classifying it actually, no? We're putting this into 2 columns of data. So you can see here that we place it to X1 and the other one is in X2. So this will be our data, PRDF. That means that this one has been transformed and scaled into to an applied version of the principal component analysis. And then this is the result, no, of that. No? So you can see that this is the transform value. This is the original scaled, or just the typical scaled value. It's a lot of details, but you can see here that they are classified into two values here, X1 and X2. And then we need those 2 because we're going to classify them. And we put them into a plot, the X1 and the X2. But here we can see that there's no way that we can classify them, no, because they are all scattered and the points are similar to one another. Okay, so how do we classify them? By applying the k-means clustering. So the first number of cluster that we did here, it's because the number of clusters by default is equal to 8. No? And since we only have a few number of data points here, so you might want just 3 is enough, I think. And then we fit the model, and then we do the prediction. Okay, and then we do the cluster center, no, where we put all the variables in center, and then we make prediction. And so you can see here, we were able to predict the clusters, no, in terms of 0, 1, and 2. So we have 3 clusters that are present here in our predicted values. All right, so and then we plot the predictions, no, of the clusters. Since we have predicted values here, we can put them into data frames, no, and all of the zeros will be placed on DF1, 1 will be in DF2, and all of the 2 will be placed on DF3. And then we'll plot them. And as you can see, when we run this, so you can see now the the distribution of the data points in terms of the clustered information, which was produced by the k-means, no? So the what do you call this? Okay. So the cluster center, this one, will be used to identify the centroid, no, which is the center of the cluster. So the centroid is defined as the centroid, or the center of the classes. No, it's at the center, no, computed as in the center of all the members of the cluster. So you can see here that if we print the square or the sum of the square distance of the sample to their closest cluster center, it's about 116.11. And here is a function that calculates the purity score. So basically, yung purity score, I've searched it from the internet, that the purity score is calculated by, ito no, yung kaya natin in-import yung linear sum assignment because we want to calculate the optimization, no? Yung cost matrix. We want to maximize the and we want to solve the linear sum assignment. And by doing that, we will be able to compute for the purity score. So this is just the function to do that. And here is the application to compute for the purity score. No? So it is done by the predicted values, and then we put the number of species. And as you can see here that we have around 83%. All right, now that we have obtained the purity score, so that means if it is close to 1, that means we have a very high purity score, and that's better. Okay. Now you can see here how we were able to do some elbow method, no? So this is what we call an elbow method, where we try to determine the best score for the k-means clustering. So you can see here that we will be using the inputs of x1 and x2 to do that. And as we have already obtained we want to know if the score of the purity score will change if we have the k values will be changed. Now, for example, here we have 2, and then of course we already have the 3 a while ago, and then 4 up to 7. Okay, so you can also make use of this by using a range, no? For example, in a range of 10, that means from 0 to 9, okay, you'll be able to detect the number of clusters. But there's no such thing as 0, no? So you might start by 2 or by 1 if you want, no? So let's try to run that, and now we will be able to plot the result of this, because we want to establish the plot, no? We want to know the purity score for each iteration, no? Now, as you can see from here, we can see that the plot here, no, from this part, we can see that the elbow is in the 3rd. And as you can see here, this is the plot for the sum of the squared error. And then this one is to compute for the scores, no, for the purity score. And as you can see, the highest purity score is on the 3. Okay, on the number of clusters is equal to 3. Okay, K here means the number of clusters as well as here, right? Although the sum of squared error becomes very low until the 7th, but it doesn't matter because if you see on the comparisons of the purity score, the highest here is really K is equal to 3. All right? So that's an example of how we were able to implement K-means using the dataset IRIS data. And I'm going to apply the same dataset for the Gaussian mixture model, no? So itong Gaussian mixture model is reported kanina, and this is one of the distribution-based model, which is in the concept of probability. Okay? So Gaussian mixture model is done by importing the Gaussian mixture model, of course. No? So you can see here that initially we determine the number of clusters, and we use it as an input for the number of components for our Gaussian mixture algorithm. As you can see here that there are a lot of parameters here, and the default parameter is equal to 1 for the number of components. The number of components describes the number of clusters. And then what we do here is to fit the model. Okay. We'll fit the model, and then this is the predicted model here. The prediction. As you can see here, the total data log likelihood is also computed. No, if you take a look at the what do you call that? If you take a look at the definition of the log likelihood, so basically, itong log likelihood, I researched that a while ago, and I saw that the log likelihood is computing for the maximum, no? It computes for the maximum, and it's a measure of how well a particular model fits the data. So you can see here that the data log likelihood from the last iteration of this model, since we applied the fitting of the model here, on the last iteration, it scored negative 2.53. Okay. Now, so next is we run these codes so that we will be able to plot our clusters. So we have 3 clusters to begin with. So you can see that these are the result of the current clusters. So you can see from the first example, it looks the same, but there are also some differences, no? Because this one is a different algorithm than K-means. And as you can see here, the purity score is around 87.33. It's much higher than the K-means. I remember that the plot above, as you can recall, no, it doesn't look like this, no. I think there are more number of black dots on the GMM than the other one. No? Something like there are plenty of dots over here. Okay, and the log likelihood, as you can see here, just to give us some background, and just to use an elbow method here, you can see that the plot allows us to see that this is the typical elbow that we can see that I think the elbow is on the 4th which means the best score here will be on if you have a cluster of 4. And this is the purity, okay, the purity score. So, basing from this, from this graph, and you see that the elbow is in the fourth cluster or 4 clusters. All you have to do is to apply the 4 here. You can change it here, and then you'll see if you change this to 4, what will be the output. So let's try. You can see, oh, there's a problem. Yeah, expecting 3. So we cannot change it because it was already, ayan. If we try to, we might want to do it all over again here. It's because we changed something here, no? So let's try to repeat that here. Now when we try to load the values, because we need to apply it there, no? So it's not appropriate to apply the other one there. Okay, so here's the plot. Now it's the same. Now for the Gaussian mixture model, now it's okay now. So here, we were able to plot and the score now becomes, still 87. And the score here for the plotting of the, you can see that the elbow is not on the 4th, but it becomes on the 5th. It changes, no? Nevertheless, we are able to apply. It doesn't matter what is the score, no? As long as we were able to apply. We're not focusing on the classification model score. We're focusing on how we can implement the data set. For the DB scan, which is another clustering algorithm based on density. So it's focused on the density and not on the distance. So the first thing that we need to do is to import the DBSCAN model and the algorithm from scikit-learn. And as you can see here that there are default values. So this algorithm performs the clustering from vector array or distance matrix. So DBSCAN stands for density-based spatial clustering of applications, no? And it also yung report kanina ni Ma'am Lakbawan, no? Medyo it includes the noise, no? So yung noise, it's also part of it, no? So that means when your data set has a lot of outliers or noise, I think DBSCAN is applicable. So let's try to see, and as you can see that it was able to uniquely predict values here, such as -1, 0, and 1. And then this is the way to plot the 0 and 1. So we're able to have just two kasi wala naman tayong negative values. So we just want to cluster it. The -1 stands for the outlier. So 0 and 1 lang yung prediction natin. So we can see here that this is the typical plot of the DBSCAN prediction. For the agglomerative, no, which is one of the hierarchical clustering methods. So, try natin siya na i-import. And then, here, for the model, we use the number of clusters as two, just two. We also apply the data set. We're still using the same data set. No? We're not changing data set. So let's see. You can see here that for the cluster, we have 0 and 1 since we only have two clusters. And then let's plot it. And as you can see here, here's the plotting obtained from the agglomerative clustering algorithm. Okay, so each of the algorithm differs from one another, but the way we apply it, so we can see the differences, and those differences can uh, uh, can allow us to think that which one is better. Now, after that, as I mentioned a while ago, some of the algorithms that was discussed is not applicable for demo because of the time constraints. And I will show you the Perceptron, and I'm sharing it to you right now. Let me just share it. So let me share it to you. Copy nyo na lang po yung link. I can access the file. Are you using the TIP? Because I shared it only on okay, let me repeat it again. So ito po yung may TIP email na. And then sa Perceptron, ito po yung sa baba yung sa Perceptron. Paki-check po if it is okay now. Can you access it? Okay. I think it's okay now. So let's proceed with Perceptron as I will be using the same data, iris data. And as you can see, even if we are using multiple, we can use it on the same data set. No? And as you can see here, what I did is to import the data. Okay, let's try to import the data. It's connecting right now. And it's mounting the drive. And okay, so this data is the same, but it's different from the data set that we, because this one has, if you will compare, I have two types of data, iris data on the data set. So I guess you can see this one. On my data, I have iris data, and the other one is the iris data with small, ayan, with small, with the lower cases. No? The other one is with the capitalized. Now, this is converted into a NumPy array. As you can see, this is the data that we can see. So it's an array. But these are all the data that are obtained on the iris data. Okay, and these are some of the visualization of the data, just to give you some idea of the so we basically classify setosas as red, and the versicolors are in blue, and then we plot it here. So these are the plotting from the data set, and then we do the train test split. Okay, so we have 70 data. No, not 70 data. We will be using 68 for our training sets. And 30% of the total data will be used for the test. Okay? And then from sklearn metrics, we'll be using MSE for the evaluation. And as you can see, we created a class here to define our perceptron model. Okay? So the first one is the initiation or initiator. So which means we'll be defining the perceptron. We'll be defining the learning rate and the number of epochs. And we define it at 0.01 and 20. No? So the learning rate is like if you are familiar with stochastic gradient descent, so the learning rate corresponds to the how big or how small is the step of learning. Okay, so this is 0.01. And then the number of epochs is the number of how many times the training will be evaluated. No? And then we considered it as learning and epochs. Now, as you know, this is an object-oriented programming. So therefore, we need to initialize it using this constructor. And as you can see here, we define the attributes for the class Perceptron. And these are some of the attributes here, learning and epochs. And then this one is a method. The method will be used to predict the object, which in this case the object is x. All right. So the x here will be used as our data set. And then, of course, you can see that the perceptron is a function using the dot product. Okay, so the dot product will multiply the values of the weight of the input and the weight, and then we have here the bias. Okay, and it will return 1 if the predicted value is more than or equal to 0, else it will return 0. On the other hand, we also have another method here. This is the method for fitting the model. In fitting the model, we'll be using x and y, which is our data set here. Okay. So you can see that to do that, we initiate the weights and the bias. And as you can see, these are the function to do that. Updating this is the cost function. This will be the objective function. And then this is the part where we update the weights and the bias. So you can see here that, and then we append the cost epoch. And then we print the model improvement here. And then it will return. Okay, so let's just run it because it's only a function. It doesn't do anything yet. But here, during the fitting of the model, we call on the perceptron model that we created. And then we train and fit the model using the X-train and the Y-train model. And as you can see from here, it prints the number of epochs, the loss, and then the regression. So let's try to do that. Madali lang naman to. Ayan, mabilis lang. And then this one is just the visualization of the mean squared error in response or with respect to the number of epochs. So you can see from epoch number, what do you call this? This is something like 3.5 or 4. Bumaba na yung number, yung ano natin, yung error natin. Okay? And to visualize our confusion matrix, since we're doing classification, so here's our confusion matrix. You can see that we have a better confusion matrix, no? Because we obtained 0, 0 here. And out of this 68, we're able to predict the setosa and the versicolor correctly. But for the testing sets, it's still the same, no? For the testing set, which composed of 30 data, so we're able to get true predictions for setosa and versicolor. Now, there is also a way to predict, to compare every single result, no? So this is the code to do that. You can see here that the expected value is compared to the predicted value. And as you can see that everything that was predicted to be 0 is 0. And all of the predicted 1 is 1. So 100%, no? So maganda tong Perceptron model na to because it was able to learn the predicted values. So you can see this is an example of trying it out. If we provide a petal length and a petal width here, it will identify if it is versicolor or setosa. So you can see that this is a versicolor because of the petal length. But if we change the value, I don't know the value of setosa, but if we try to put 3.5 here, for example, so you'll see that it's a setosa. No? So that means the petal length of a versicolor is bigger than, or ano yun? Mas mahaba, no? Mas mahaba siya kaysa sa petal length ng setosa. So that's the difference between the two. And the machine were able to predict it right. Okay? So that's the perceptron. No? What about the neural network? So this is your neural network. Actually it's already shared to you. Ito yung magiging activity number 4 nyo. But I will share it to you na ngayon para baka mamaya hindi nyo ito ma-access. So I'll be sharing it to you now. This is the notebook that you will use. Right? So for your activity, I'll be showing you the first part of the activity of the neural networks. So I'll be using APIMA Indian set diabetes data set here. Okay, so it's also included in your activity. It's also already in the canvas. And then the first part, of course, as you can see here, some of the most notable libraries here that you may want to use are the following. So ito yung ginagamit natin for splitting the dataset, for standardizing the dataset. These are for the metrics, and then we'll be using a random forest classifier ensemble for our neural network. So let's try to import that. And then for the neural network, we'll be using the sequential model. So you can see that I'm using the sequential model to build the deep learning. No? Kanina, a while ago, I remember that Mr. Munar mentioned what is the difference between a simple neural network and a deep neural network. No? He mentioned that if the hidden layers of the network are more than 3, then it's considered to be a deep learning network. However, if it is less than that, that could be considered as a simple and not deep learning network. Okay, so here we'll be using the sequential model, and as you can see, some of the terms here uh, somehow be, you should be familiar it with, for example, the input part of the network, and then the dense part. The dense part is sometimes we call it the output part, and then the flattened layer where your data is flattened, and then we have this data here called dropout. So the dropout layer, from the definition, it randomly sets input units to 0 with a frequency of rate, blah, blah, blah. No? So basically what it does is to drop. No? They drop all they drop all the layers that are needed. Okay? Or randomly drop them. And then the batch normalization, yeah, it's just a class that we need to use later. And then for the activation function, you can see here that we have 3 activation functions here: the Adam, SGD, and the RMS propagation. Now, the data set that we'll be using is the PIMA Indians data diabetes. So let's try to load that. So the file was not found, maybe because I am not, yeah, hindi pa tayo nakamount, kaya hindi pa tayo, yan. So I will connect now to my drive para ma-access natin yung dataset natin. So you can see here that once we load the dataset, so you can see here that it's okay now. You can see that these are our dataset. Checking on the 5 samples of the data, we have these values here. Let me just close this one. So these are all the names of the columns, no, based on this: times pregnant, glucose tolerance, blood pressure, skin thickness, insulin, BMI, pedigree, function, age, and the classification, whether it has a diabetes or none. This is the classification. It's like a binary classification, okay? Because it's only 1 and 0 that we're talking about here. All right, so these are the data types of that we have. So we have integers and a combination of float in the BMI and pedigree function. So yan. You can see here that we split the data into X and Y. So this will be our Y, whether they have diabetes or none. And then we use the test train split function, and we feed the X and Y here. 75% will be used for the training, and then 25 will be used for the testing. All right, let's do some samples. For the Y and the 1 minus Y, you can see you can see the data set. We have these values. And let's try to build a single hidden layer network using 12 nodes. So gagawa tayo ng isang layer lang, single hidden layer, and it has 12 nodes. And we will use the sequential model with single layer network and the input shape to 8. So the input shape must be 8, okay? But before we do that, we have to normalize the data first. So we transform the data into the standard scalar function, and we did the model here. So we see that the sequential model was used, sequential class, and then you see here that the input shape is equal to 8, with 8 dimensions, right? And it has 12 hidden nodes. So 12 here corresponds to the number of hidden nodes. And then the activation function that we are using here is the ReLU. Now for the output layer, we only have one, of course. Now we just need 1 or 0. And then we put another activation function, which is sigmoid. So sigmoid function is an activation function that is best for binary classification. Wait lang tingnan ko yung definition niya sa internet. Ayan. Yan, sabi niya. It's best for classifying 0 to 1. The sigmoid function. So parang logistic regression, no? From in between 0 to 1. Okay? So sigmoid yung gagamitin natin na activation function. And activation function, as described a while ago by Mr. Munar, so the activation function acts as the threshold which forwards the layer, forwards the activated function or not. No, depends on the threshold value. Okay? So that's the essence of the activation function. So katulad nito, sa input part, meron tayong activation function and as well as on the So nakikita natin dito na sa input part, wala tayong ibang layer maliban dito. No? Isa lang din yung ating hidden layer. At isa lang din yung ating output layer. So let's try to run it. And what happened? Sequential is not defined. Okay, let me just check it here. Sequential. Where is sequential here? Okay, yan na. In-import naman natin si sequential. Model. And it says here, name sequential is not defined. Let me just check Kanina, it's working na I tried this a while ago. And I even have this sequential. Okay, let me just retype it. And run it again. Okay, sequential is still not defined. Let me see. Dito, niran ba natin to? Yes, we did, di ba? Okay. And let's try it again. Yeah, it's okay now. See, di pala natin na-run kanina, kaya pala. Okay, I was explaining it, I forgot to run. Okay, so na-run na natin yung model natin. Let's view the summary of the model. And as you can see here, we have an input layer which has 12 hidden layer, one hidden layer but 12 according to the one hidden layer but 12 hidden nodes. Yan. And then we have one output layer here. It's just a very small network, 121 trainable parameters. And let's try to run it. As you can see, the function that we use to activate this is for the fitting of the model. We use the SGD as the optimizer. So the default optimizer dito, kung titingnan natin, is RMS prop. You can see the optimizer default is RMS prof and all of the others has none. So yung isa lang ang binago natin dito, no? So dito, what we did is to use the SGD as the activation function and we put 0.003 as our learning rate, no? So ito yung mga parameters na pwede nating baguhin later on, no? If we want to optimize the efficiency of your model. And then we have this binary cross entropy. So this is used for basically for binary classification. And then the metrics that will be used to evaluate this is accuracy. So we can print the accuracy later, or we can plot it later. And then we fit the model and we place it in this variable here. We use the train and the y train, x train, and the x train normalized and the y train. For the validation data, we'll be using x test norm and the y test. And the number of epochs will be 200. So the default for the verbose, kung nababasa nyo yung verbose, pwedeng iset yung verbose. Wala yatang verbose dito. Wala siyang verbose dito. Pero yung verbose, pag nababasa nyo yun, yun yung if you want to see or not the activities, no, that happens while you are training the network. Like here, so if I click that one, you'll see that it will run 200 epochs. And as you can see, the loss and the accuracy are printed as well. Mabilis lang naman yan. So you can see that it's almost done, and it's done. Okay? So now let's try to create some prediction. But there are two predictions here. We'll be using some probabilistic scoring here, and then the other one is yung the other one is in terms of classes or the binary classification. So let's try to do that, predicting using the X test norm. And then we have these two classes that you can see. So the values that can be obtained here are floats. So hindi siya zeros and ones. So therefore we need to do something, no? So ito yung nakikita nyo. As I mentioned, yung values na makukuha natin is, this is from the range of 10 values. Nakikita nyo na decimal siya, no? Fractions. Okay? Ganun din si probability, fractions din siya. So paano natin mako-convert yan into zeros and ones, no? If we want to predict the neural network. So to do that, dito muna tayo. Let's do the rounding up, no? Dito kasi sa accuracy, pag pinrint natin yung accuracy niya, we need to round it up, no? And if there are negative values, we need to provide the absolute value of that. So you can see that dito, yung na-obtain natin na value dito, kasi kung hindi natin ginawa yung rounding up at saka absolute value, we might encounter floats, which there are mixture of floats and whole numbers, no? Because we have a lot of data there. And as you can see, it's a combination of mix, and it will have an error, no? On the original notebook, wala nito. I just found the solution that if you have mix, and if you want to know the accuracy score and you're performing class prediction of binary, and it should be predicted into zeros or one, you need to round it up, no? By logic, I remember that there is a function to round it up to the nearest value and then the absolute value of that. But for the ROC under the curve, no, you don't need to actually calculate, or you don't need to convert the value of the probability score. Now you can see here that the accuracy is around 766 and the ROC is around 81%. It's a good score. Okay. Now we see that we can also run the plotting, and as you can see, the plot of the training looks like this, no? That the training loss is somewhere here, but the validation loss, this is the validation loss is used for the training, for the test data sets. No? For the red part, this is the training data set. Well, not so good, but typically maganda na rin siya. No? So you can see in terms of interpretation of the train and validation loss, somehow okay na rin siya pero hindi siya masyado pang maganda. We can still do something on the neural network. Okay? Because it's supposed to be somewhere like halos magkatabi yung validation loss natin tsaka train loss. Now your assignment, now this is your assignment. So you will build a model with 2 hidden layers. So pinweak natin, each with 6 nodes. And you will be using relu function for the hidden layers and sigmoid for the final layer. The same pa rin, no? But the learning rate is 0.003 and the training epoch, number of epochs is 1,500 instead of 200. So you don't need to print all the 1,500 epoch, no? Pag sinubmit nyo yung PDF file nyo, pwede nyo itago yung 1,500 epochs. Okay? I just want to see the graph, no? The trajectory of the loss function and the accuracy on both train and test set, and also the ROC curve. And then, if you want, you can use different learning rates, number of epochs, and different network structures. No, so try to do something if you can still improve the scores that you obtain from the example. And then, of course, you'll do some interpretation, conclusions, and that's it. Okay, so that's our demo for tonight. Sumobra na yata tayo ng oras. Umabot na tayo ng mahigit 3 hours dito. But it's okay, no? We have plenty of reports naman kasi. Bumawi lang tayo from the past na medyo maiksi lang yung klase natin. So if you have some questions po from our demo, from our other topics that we discussed, please chat your questions or any other inquiries. Now I'm stopping the recording now.